management. So we're continuing implementation on everything we can throw the infrared at. I'm involved heavily in the electric vehicle program and electric batteries, trying to help out both those folks. They both need help on how to do certain operations and guarantee they're done right. So they're really open-armed about it. They love what they see. And they're using it now as a tool. We've linked up with ASNT, American Society for Non-Destructive Testing. We have a great certification program, and that'll be reinstituted as soon as possible. We've launched programs like reliability and maintainability, R&M, to go in and work with vendors that are supplying tools to GM and utilizing some of the tools that you've seen today to buy off that equipment. Make sure during the runoff that everything is being done correctly, that that machine or that operation is doing what we spec'd it out to be. If that glue is supposed to be 400 degrees coming out of that robot, it better be 400 degrees. Just don't take the guy's word for it, measure it, okay? Design of new infrared products. It's kind of out of our hands. I think more of the applications we help out and things like machine vision. But every time we get a new design, we take a look at it and see if it applies to something that we haven't been able to do. And then certainly solve our problems with thermal vision. And then if we can't monitor or run it with simpler IR techniques or maybe another technology, I certainly don't want to push infrared if it doesn't work. You know, we might have to solve it, but it may not be the right tool to monitor that process. A flow meter might be the right thing, or some other simpler technology. Why put on inexpensive infrared and go through the commissioning of it and the maintaining of that if we don't need it? Solve it, put on another process monitor, move on with your life. There's plenty of other work for you to do. So ASNT is a pretty worldwide society to work with. We've done a heck of a lot of work with our national labs. It's been a real exciting adventure working with folks like US CAR, being able to meet and learn of all the scientists and all the capabilities across this land and working with those folks. We've got hundreds of national labs, big and small, and boy, they're all just terrific folks to work with. And utilizing them as much as possible is critical. Just a quick story on Oak Ridge, an example. Nobody really knew about electrical signature analysis. We had heard that they were going to give us a little report down in Oak Ridge on some of the things they've been working on. So we jump on an airplane, take a couple of days out, we go down and they tell us about this technology, that technology, and two scientists stand up, a guy named Steve Smith and Howard Haynes. They invented a thing called electric motor diagnostics, or electric signature analysis. We take a look at it. They designed this technology to look at motors and what the motor current is telling us for the nuclear industry. If a motor controlled valve has a hiccup or a chain broke, they can clip in on electricity supplying that motor and can see that that motor's having some difficulty in the reactor, but do it in a safe spot where the power's coming in. So we're looking at that and we're going, you know, 60 to 70% of our whole industry is run with electric motors. Why don't we buy into this and see what it can do for General Motors? There weren't too many people making equipment when they first discovered it, so we kind of had a couple of dead ends. But then a couple of companies started putting out some wonderful tools in electrical signature analysis. We bought into it and it's just fantastic. The motor is its own sensor. Anytime there's a hiccup on what the motor's running, you can read it on the current signature of that motor. There's software programs to monitor those signatures. You can do both online and offline. Any motor in the world can be tested quickly. AC, DC, variable frequency drives, all done very, very nicely with electrical signature analysis, except who would have heard about it unless we went down to Oak Ridge and listened to a lecture. So it was pretty amazing. By putting a little bit of time, getting involved, learning about it, and trying it out, it paid off in spades. And I would like to see this on every car, every vehicle in the world. If you can monitor every motor, why not have it monitor our generators, our alternators, our window wiper, or our windows going up and down? We could have self-diagnostic motors by putting electrical signature on everything in our car and do it pretty economically. The vehicle, your car is the biggest user of DC motors of any appliance that you'll buy. So we got all of these DC motors on there. Why not do electrical signature analysis? So someday you'll see that. I don't know how soon, but but empowering our workforce, giving the owner-operator more responsibility is really paying off, educating those guys, training them, and adopting an owner-operator concept, letting those guys, those smart folks that run those processes, tell us if there's anything going wrong. Listen to these guys. They really know what they're doing. Exploit the internet as much as possible and get vendor support like John and Barry or whoever you're working with. Get them on your team. That's help. That's money for nothing, you know? It's help. Explain to them. Once they know your criteria and your urgency, they get on the ball. Instead of going to some other sales event, they might stay back and send you the right data or take care of your service needs or put a new idea in for on the next generation thermal imager and make your world a little bit better. University collaboration is really wonderful to see students like U of M, Oakland University, things like that. Just working with universities. We had a great study with Berkeley National Lab, Deb Hopkins. It's just great learning from these folks. And then studying or sponsoring your students, getting them in for a summer, giving them some simple projects, let them carry that, crusade that technology forward, okay? It's really paid off. So we try to combine infrared with other technologies. If we get two technologies pointing to the same root cause, we go with it. Don't argue with that. And then use the infrared, that temperature signal, that heat signature is there. You just can't see it. You turn on this stuff, it's all there. All that information starts coming out at you, and all you gotta do is solve that little riddle. In most cases, like you saw, it's pretty simple. Something's not right, something's out of balance. It's not rocket science. It's just waiting for us to turn it on and point and shoot and focus. You gotta focus. If you don't, you're not gonna solve any problems. This is a sign I wanted out in front of every one of our plants to warn our suppliers, warn anybody coming on our property that we're using infrared technology. Don't try to fool us. Don't try to pull the wool over our eyes. We're gonna solve it sooner or later and hold you to it to make it right, okay?